around the bright sun, which Wolf and others put foundation to produce the solar activity. So this is the solar activity which is 10. This is the number of sunspots per every 11-year cycles. For cycle 12, 11 to cycle 23 in this part. And this is a butterfly diagram, or where sunspots occur, somewhere within royal zone, between 30 northern and 30 southern, and over the cycle migrate to the equator. So it was very fine, nice, until we got European Grid of Solar Observations funding. I got European funding in 2002, and my group was leading automated detection of the sunspots on the disk, active region, and filaments. So when we did detection, we discovered, of course, why the sunspots come in pairs, because they cover actually the food points embedded into the photosphere, basically the root of the tree. So sunspots are root of the tree, what you see. And above these roots, you have big magnetic loop which form active region. So this is how sunspot look, magnetic field lines, and we see sunspot pairs. So obviously they're much more than sunspots in solar activity. So what we did, I skipped the slides about my detection because we reported this many times, European Grid of Solar Observations. So we basically produced very nice grid of 12 years of daily data on the solar surface. All the sunspot, magnetic field, inclination, distance from the equator, everything. Whatever you can imagine to find from solar image, we got it. And we got digitized, nicely described and pointed. So just explain what is the solar activity. When you have the solar activity, minimum, your sun is flat, nothing there, even no sunspot. And then this is in X-rays, soft X-ray. When activity increases, you see the sun is absolutely flourishing, covered with many active regions, and the active region sends coronal mass ejections towards the Earth and other planets. Normally, during the maximum solar activity, we have a few tens flares per day or few flares per day. It's not in this cycle, but in previous cycles. Why this is happening? Why the solar activity happening? With general understanding, the magnetic field of the sun, like say beginning of one cycle, the minimum cycle, north polarity on the north, south polarity on the south. Then the sun rotates around the axis, and if you never heard about it, you know that what is it? Come on, here. So during minimum, this is empty sun. Then loops appear on the surface, and because equator rotates quicker than poles, these loops started twisting and forming these active regions. This is called solar dynamo in action. So these are formed, this is called toroidal magnetic field, which is very strong magnetic field, up to a few Gauss magnetic field in here. But embedded, this sun is into poloidal magnetic field, which is maximum from few Gauss to 40 Gauss. So basically, what is happening in here, during the maximum solar activity, when these loops are formed, the polarity south and polarity start migrating through these loops from the south to the north. During the maximum, polarity is completely twisted. Sometimes poles have the same polarity, both poles, because they twisted. And when we reach the next minimum, voila, the northern polarity becomes south. On the north, we become south polarity, of the south-north. We need another 11 years to return to this point. So this is how solar activity works. Why I told you this? We got this sunspot for 12 years, for cycle 23, and I thought we will introduce automated solar activity index because I have everything power. I'm smart mathematician, I run artificial intelligence, everything. But we couldn't fit how people produce the sunspot numbers. They put a lot of individual perception, which you cannot quantify. So we tried then to put detection, derive the cycles in this, put principal component on the sunspot. But because the sunspots are so tiny, it's 1,000 area of the sun, error bars were huge. So you were stuck until we did paper 2008 with Gavriusem. We discovered that, just a moment. Here are our sunspots, leading polarity northern in that cycle which detected, trailing polarity southern. And this is background magnetic field with the low resolution. So we don't see a sunspot in this. It's a Wilcox Solar Observatory. But we discovered that polarity in which the sunspot appear actually opposite to the polarity of leading polarity of sunspots. So what we then investigated in this paper, we discovered that actually it was this background field which allows sunspot appear on particular surface. And first 2 years they appear in the northern hemisphere, while in the southern hemisphere they migrate to the equator. The next 2.5 years in the northern hemisphere they migrate to the equator but appear in the southern. So we discovered this separation, and suddenly it occurred to me, oh my God, it is background magnetic field which allows this sunspot to appear. They're actually the product of the whole background magnetic field. I was not the only one. We had Stix, very famous German scientist, who already spotted it, 1976. Nobody picked it up. But then we picked it up with Gavriusem.
Sorry to interrupt, but could you explain what you mean by leading polarity?
Leading polarity, okay. Let's come back to the sunspots.
And what was your point about leading polarity there? Because not knowing what you meant, I didn't follow it.
So here are the sunspots. So in this particular northern hemisphere, you have the sunspot, which is closer to equator. It's called leading polarity. It has larger magnetic field. And this is the trailing polarity. So it turned out
whichever is so leading is nearest to the equator.
Yeah, leading polarity is because they're migrating toward the equator. So this is the loop, and they're trying to get to the equator over the 11 years. So this leading polarity normally, as you shown in the picture, is much larger than trailing. We don't see everything trailing. It should matching, but sometimes they're matching across the equator. Sometimes we have trans-equatorial loop to match, to connect them. So this is why this leading polarity defines where sunspots can occur. And they occur obviously with the northern polarity.
So what is the message of this slide, please?
Message of this slide, that sunspot can only occur when the background magnetic field has polarity opposite to the leading polarity. Okay? It allows, if polarity is southern and sunspot appears with the northern polarity, it attracts.
So what do you mean by background magnetic field, please?
It's background. I just
background measured where?
In this solar photosphere here. So here is your background magnetic field. Is there like water on the sun? And this is the sunspot magnetic field loops which appear like those twisted loops. So all this orange is leading is a background magnetic field, and this is sunspot magnetic field, toroidal magnetic field. Background magnetic field called poloidal magnetic field. Is it clear now?
Okay, thank you.
Okay. So what we can do now, we want to, you see that magnetic field, we had 1024 pixels. So how we can deal with them? When you put simple magnetic field, and you cannot do anything with them because you have interference all the waves, and we don't know which waves are there. So what we needed at that time, realized 2008, 2009, we needed something like this glass prism with the white light. If you put white light on the glass prism, because of different diffraction law, on the right-hand side you get your rainbow. You get red, orange to violet. So I needed something like that, but for magnetic field. And for magnetic field, the only thing is working is principal component analysis. And it is not brand new analysis. It's done 1901, it was invented. So when I started using 2010, it was 110 years later. And many people used it for everything. So when you put solar magnetic data for principal component analysis, you get eigenvectors, or frequency of all oscillations of the wave. Similar like here. These are eigenvectors of the white light, red one, all this frequency. The similar, I get eigenvectors for magnetic field. But they look slightly different. They look like this, they call it scree plot. So you see, here is eigenvector value, the first two. These are two eigenvectors which are classified by variance of data contributing to this eigenvector. Eigenvector is the same natural oscillation like on that bridge, the Tacoma bridge. So in order to find own oscillation, I need to run principal component, get own frequencies. This is what I've done with the sun. I'm surprised that nobody did it before. They measured this magnetic field for 3 solar cycles for 40 years. And didn't bother to run principal component, find eigenvectors. Anyway, we found these eigenvectors. And here are the first two. We found they come in pairs. It was 2014 when we found this. Maybe 2010 we published first paper. So they come in pair. This pair, the largest principal component, they cover 39% of variance, which is 67% by standard deviation, square root of variance. Then you'd have the next pair, and the next pair, and the next. So we use only 4 pairs. These 4 pairs cover 99% of variance of the data. But at that time when we found, we had no idea what they cover from. Later, we discovered that the first pair should cover for dipole magnetic field waves. This pair covers for quadruple magnetic field waves. And I'll speak you in the talk what we discovered. So anyway, what we discovered, that we have pairs of magnetic waves. But in theory of dynamo, with this, remember I showed you how toroidal field formed, converted in poloidal, and poloidal to toroidal. All the models assume that there is one dynamo. One dynamo wave, and then somehow they do all this interaction. We got 2. It took me a whole year to find any guy who does dynamo to look at this data. I said we need to see how it's possible. So anyway, so what we got, this is what we got from observation. Everything before that one, what we got from the data. So we got this full disk magnetic field, 1024, 1024. We ran principal component, and we got these 2 principal components, blue and red. Blue and red, they start from different hemispheres, cycle 21, but they meet in the northern hemisphere, cycle 21 and cycle 23, even odd cycles, and meet in the southern hemisphere, cycle 22, cycle 24. And when they meet, you know, the resonance, that is why we have large solar activity. Fine, we got this, and these were this data we didn't have yet before. So we decided, while we finished this part, this 5 years came, we decided, okay, let's check if our results correct. So what we did.
Sorry, red and blue are dipole and quadrupole, are you saying? The 2 first components?
Quadrupole is all dipole. It's 2 waves coming from 2 magnetic field, north and south. But they come from 2 So these are come from dipole magnetic sources, north on the northern pole, south on the south. But we have two waves, not one. Okay? Is it clear?
Well, I'm trying
Okay,
to follow.
try.
Thank you.
Maybe you need to wait for a while and then you ask questions. I'll have the whole time for questions.
Okay, if you prefer.
Okay. So,
It's just, you know, sometimes if you lose early on in the presentation, then the whole presentation can be lost.
yeah. But you need to have some kind of background to understand it. So we have these two waves coming, and we needed to predict, if we can predict these waves. What we did, we ran, this is kind of sort of artificial intelligence. No, at that time, the guys who was Schmidt and Lipton, they offered free software called Eureka, in which if you have clear wave, like we separated into two principal components, we cleared all the noise. So when we put these waves into Eureka, it gave us the formula for each wave. This is a formula for blue, this is formula for red. Analytical formula will describe these curves in here. And when we checked this formula, these are the results we derived from observations with this dashed curve. And these are the results, solid line, we derived from the formula. The accuracy was about 97%. So we got, because we cleaned our principal component, Eureka gave us the formula. And of course, if you look at the formula, no one in Dynamo predict that you have a product of two cosine functions, and even your phase relation, one wave runs away from another, and also is cosine function. So this is what most important thing. But to understand what we got, you understand that we got mathematically. We need to understand what it means physically. We decided to add these two ways. So if they go in the same cycle, in the same, so when we added, we got this historical data. This is the part which we can predict. It still predict nicely data. And what we discovered, that amplitude of these waves keep decreasing. Is the cycle 26, you see amplitude decreasing. What does it mean, this amplitude? Well, we move here. We decided to compare our summary curve, or modulus summary curve. What we did, this is our summary curve. So in order to compare with the sunspot, we got negative polarity for southern hemisphere. We put it to the positive reflected modulus x to the top, and we got this data. These are red are sunspots or toroidal magnetic field, and black are our colloidal magnetic field. So they're not fully fit, but they follow the trend. So we can say, this is how we figured out that, yes, these two principal components are responsible for the variations of the sunspots. And you see in the cycle 23, we predicted that this magnitude has to be much lower, and they found that the guy Sergio Cartesi in Locarno, he multiplied by 3, they needed to reduce this one, but we predicted it. So basically, we thought, yes, it gives you description that sunspots are actually described by dipole magnetic field. So now we come back to our curve, okay? It's 23. Cycle 24 and 25 needed the same polarity, but look what happened. Amplitude of cycle 26 reduced by 70%, from 400 to 100, or less than 100. Recently we done the paper, published and Ras, for adding the data for whole cycle 24, predicting 25 and 26. And you see they still fit in very well, or reasonably well, given that these are different entities. So this is my colloidal magnetic field, background field, and red are toroidal. which appears and related to the differential rotation of the sun and many other processes. So basically, what it says that indeed we can say that our summary curve can be kind of another additional index of solar activity. And then we started looking further. Why I gave you the picture about these waves before lecture. So if you have two waves which run out of phase, one wave is running ahead of another. If these two waves come with the same amplitude, amplitude of wave is increased by factor 2. But if wave come opposite amplitude, the amplitude of resulting wave becomes 0. It's called wave interference. And wave interference is very simple. Again, it's part of my lecture notes for students. So if you have one wave is natural frequency of the layer near the surface, and this is wave coming from the bottom, from dynamo, from Ptakov line, they started interfering. How they interfere? It's cosine function. And when they interfere by cosine function, what is happening? Your amplitude is fluctuating as sine equal difference of frequencies, while the period is equal half sum of the periods of two waves, right? Voila. So what we got, this is your normal 11-year cycle, which have envelope oscillation caused by the interference of these waves in the generated somewhere in two layers. And this envelope oscillation produce you grand solar cycle. And between this grand solar cycle, it produces you grand solar minimum. This is how we got it. So we basically, but we didn't do calculated for that time. This is what we got from the observations. When we got this formula, and from this formula we calculated from 1200 to 3200 the summary curve. This is what we got. And these are the data which we used. We got the data which immediately struck to us, wow, the amplitude of solar cycle is reducing. We are at the verge. It was 2014-15. That's published 2015, this one. We actually are at the verge of grand solar minimum. The previous one is the minimum, and we detected it very nicely. And there will be this one, and there will be another in 2375 to 2415, and so on. And if you look in another one, the many others I will show you here. Yeah, if you want to, this result was actually reported at the National Astronomy meeting 2015, London. We had press release, and many other media, probably you saw it in presentations and media and my interviews. So now we calculated again, like yes, we have the formula. You have the formula, you run your computer for 2 days, and you get your result for 3,000 years. To minus 2,000 before Christ. We hit even numeric level, we get Oort minimum, Wolf minimum, Maunder. We didn't get spur minimum, but when I investigated spur minimum, it actually was not a minimum at all, because it was supernova Bella Junior, which was exploded 1280, which was at the distance only 600 light years from the Earth, from the solar system. And it is still the strongest gamma ray source in the sky. Imagine how strong it was 500 years ago. This is why they measured to restore the time from CO2 abundance in the biomass. You need to have background of the Earth at that time. But they calculated here background standard, which was in 19th century. But at that century, the background was 200 or 1,000 times higher. This is why this was referred probably to Wolf minimum, if not Maunder. I don't know which one, because at that time when they referred it is a Spur minimum, this is what Aurora Borealis, the strongest ever observed Aurora Borealis during so-called Spur minimum. We don't observe Aurora Borealis during minima. So it was the maximum as we predict. And this was the maximum which was causing on the background very strong gamma ray emission coming to the Earth. Even furthermore, the temperature variations, if you look at the 14th century temperature, it actually shows increase of the temperature. They didn't look at it. They said minimum. Half temperature increased during the minimum. Temperature decreased during minimum. So these guys pull, I would say, big tail, because this is not the correct one. So even the ice variations, the Vela Junior exploded at the 55 degrees of southern latitude. So only people in southern hemisphere could see. This is why none of the nodes, at that time we didn't have telescope, remember yet, 1280, medieval or even worse time. But they haven't seen the supernova because it's too far. And the south hemisphere, what was then? We don't know. And British Empire only started establishing. So, but in the southern hemisphere, you had no variations of ice. But in the northern hemisphere, they had actually higher ice in there. It is not minimum. It was like maximum because it was strong melting ice in the northern hemisphere. So definitely, even from ice in the north, it was showing it was not showing, it was not minimum. So what we thought, we found new proxy of solar activity. And how beautiful it is. We give you formula, and everyone can calculate. Were they happy? No. Why they're not happy? Because they put the whole life for 100 years describing the sunspot with solar activity with sunspot, putting the individual perception, which you can quantify. I try to quantify what they say. It's impossible yet. So this is why we thought, okay, let's live in parallel universe. They have solar activity, sunspot, and we have ours. So let's see what we detected. Why we have two waves? Why we have two waves? At that time, in 2011, it was Solar Dynamic Observatory launched, a new HMI instrument launched, measuring the oscillations of the sun, and they discovered that inside the sun they have two layers, in which they have meridional circulations running in the opposite direction. Voila! This is where we got two waves. One wave comes from the blue, and another wave comes from the red. And based on this one, we had Elena Popova. She was done Dynamo in Moscow University, the PhD, and she ran the simulations of two waves, and then calculated the summary curve, trying to emulate our. This is the observed curve from observations. You realize no model was involved here. It's completely from the data. And this is first time we try to interpret with dynamo model observations for 2,000 years. For time being, they can only do it for one solar cycle, but the cycle already started. And here we come, doing it for 2,000 years. Voila. Okay, so she managed to reproduce this cycle, shorter, higher amplitude, this longer, smaller amplitude. So you can see she managed to reproduce very nicely. And this is when we discovered that in order to get this kind of grand solar cycle of 330, 380 years, you need the difference in this meridional circulation in this layer. Only 1 meter per second difference give you this nice ground solar cycle, 350 years in general. So this is why we later, after I think paper published 2023, we managed to run the data for solar irradiance in the derived from the biomass, and we discovered period 350 years, which shows increase of solar irradiance on the Earth. Again, it was there, but people didn't know where to look. You always need to tell, look at that part. Oh, we don't want to look. Okay, it's of course a problem. But now this ground solar cycle, 300, so this one, 330, this one, 380. But in general, we have 5 ground solar cycle, and between them, 5 ground solar minimum. What we also did, because she is theoretician working with dynamo, so she can produce the butterfly diagram for among the minimum. She produced butterfly for among the minimum. This is from her simulations, and these are real measurements of butterfly diagram during among the minimum. And you see 1720, 1720, we have this blink. 1700, we have 1700. So basically, when you put the clean curve, clean from the noise, from contribution from other sources, we could reproduce pretty closely even butterfly diagram during among the minimum. After that I said, Elena, give me what will be this minimum. You said, well, please. So what she produced for the given minimum, the 20 cycle 25, 27, cycle 26 will be very weak. We will not have many sunspots, which is starting in 5 years, guys. Cycle 26 upon us. So whatever they tell you, when we done this, it will never happen, 2015. I said, just wait, 8 years. We sit in front row and we see it straight away. I'm still saying the same. So we have butterfly diagram, which we can reproduce. Then, this year, not this, last year, we compared our cycle of solar activity, a summary curve, a modular summary curve, with the sunspot, just to see, to prove it works. So we done spectral analysis, wavelet analysis of sunspots, and given the main period 10.7 years in the last 25 solar cycles. And this is actually the same wavelet of my summary curve derived from that graph. What period we have? Huh? The same one, 10.7. Of course, they are different entities. They cannot be the same. But definitely we work with the same activity of the sun. Plus, in our curve, we have this 342 year as well, ground solar cycle, which in this one we cannot see because it covers less than 350. Here we cover 2,000 years and here only 400 years, so we cannot see it. We done even better. We compared 1 to 1. So here, green is our cycle, red is their sunspot. Yeah, they cannot predict. The green has to be ours because they couldn't predict at that time 25 or 26. So you can see that at the 18th centuries, difference is huge. We run with IBM statistical package, cross-correlation analysis, and we found that for these years, 1800, correlation with our cycle theirs is 25% because at that time, who knows what the observation they put, what they write. And in this period, if you remember, it was a migration from Julian calendar to Gregorian. Migration took about half century in each country. And when they put the dates for the sunspot, they never said in which calendar. Furthermore, the new year in Great Britain, and this published in that paper, M and Russ, freely available. We paid you can download and read for free. You don't need to pay. Specifically made that everyone knows. So in Great Britain, New Year started from the 6th of April. So in January, if I put year, let's say 1820, we don't know which is 1820. Is it after April the following year or before? In Russia, New Year was starting 1st of September. Again, no one put which New Year and how. This is why some cycles in here were 8 or 7 years, some were 15 years, and they try to pretend it is correct. It is not correct. As soon as we move more quantified data from 18th century to 1920, we got increased correlation between now 56%. And when we started from 1900, they started doing really good classification with sunspots. And this is when we got 67%, which remember, I told you by variance is 39% our data, but standard deviation 67. This is maximum we can get. We need to add quadruple, octuple, everything. So obviously, we're on the right curve. We got the right thing. So what I'm saying, you like sunspot, be my guest, use them. But use this one. It doesn't ask you to eat or give you food. Just use it and see how it works. And to show how it works, we can go and, so what I remind you again, so what we moved from this toroidal magnetic field, tiny, tiny spots which will appear. We move to the solar activity defined by the background field with this orange one, which gives us much better accuracy because we found nice correlation. But just to explain you, I had Elena Popova, my dynamo person, that simulate me toroidal field and poloidal field for the same model. And here we are. This is my poloidal field, which we measured. And this is how toroidal field look for the same period. So you see they are different entity. They ought to look different. So we cannot make them look exactly because their sunspot appear from the surface. These are magnetic loops. They should look different. If we accept it, it's fine. Then another paper, 2022, with Simon, we look at the quadruple magnetic field. And what we found, that quadruple magnetic field actually corresponds to the soft X-ray index of flares. And it makes sense. If dipole magnetic field is north polarity, southern polarity, quadruple allows you to appear additional sources and produce interaction, produce flares. And this is index of soft X-ray in flare, and this is my summary curve for quadruple magnetic field we derived. So with Elena, we did add quadruple field to the magnetic field, and we got much better correlation with the sunspot because when we had quadruple field, so instead of 39%, we added another 10, 49 by variance, which gives you about 85% by standard deviation, so we're moving closer. If we move to sextuple on octuple, we can get probably full verification of magnetic field observed on the sun with this one. So, but can I bring you why it is important? Because the magnetic field we derived now correlates very nicely with the occurrences of volcanic eruptions. We published paper with Elena, with Irina Vasilieva, and we showed that volcanic eruptions, shown by black line, and red is our background magnetic field, they actually show that if leading polarity in background field is southern, you have maximum of volcanic eruptions. So basically, your volcanic eruptions correlation with the leading southern polarity is 84%, which means not only we have in cycle 26, when the polarity will be southern, not only we have decrease of amplitude of cycle, we will have increase of volcanic eruptions. And those who are younger, they will see it, and hopefully most of us will see it's another only 10 years, not so much. So definitely this is very important because volcanic eruptions play a significant role in modulation of the temperature of the Earth. I put this just to show you, this is what we have done after I made the talk, because the paper published 2023. So why it is important to know solar activity, what is happening? It is important, it was done by Eddie. He showed that temperature variation go with solar irradiance until present century, and man put this hockey stick curve. But before, it followed very nicely, increase of temperature, increase of radiation, increase of middle of last century temperature because increase of amplitude. But we know why increase of amplitude, because interference of this wave, this particular grand solar cycle had higher amplitude, as I shown you in this particular line. But what is happening, people calculated, Lin et al., she showed that during among the minimum, the solar irradiance measured in watt per square meter was reduced about only by 3 watt per square meter during that. This is Dalton minimum, was also reduced, slightly less, but reduced. Here are the measurements of reduction during amount the minimum by different authors, but they still give the same numbers. What it gives, when you have reduction by 3 watt per square meter, you have reduction of temperature during amount the minimum by 1 degree. Average temperature on the Earth. What it means, average temperature? It covers higher latitude, lower latitude, south, north. It means not particularly something important, but it gives you, I will tell you now, decrease of the temperature. And then they look at the periods when temperature was decreased, Dalton minima, and some other, in this particular, another Dalton minimum. And then now we come to increase of the temperature. They said, oh, this sun doesn't affect because now the solar activity is reducing, but the temperature is increasing. But let's look back what happened during Mount the minimum. It was Schindel et al. And Kevin Smith, who is the main protagonist of anthropogenic global warming. He is author of this paper. Maybe he was a PhD student, not the brightest one, because Schindel did correctly. But this is what he showed when the temperature is decreased dramatically during Mount the minimum. And you can get this paper in the website. If you type, if you want, I can send it. I downloaded Science, I subscribe to Science. I can send you Science paper. But it also have on the Science. So the most decrease of the temperature is in Northern America and Europe, Northern Europe. Temperature decreased by 0.81 degree. So this is half the temperature. In some places in Africa, temperature was slightly increased. Hopefully, it will be the same. We can pray that Africa will feed the rest of the world and become very rich. This is why all Chinese guys buying the lands in Africa, because they know this is the gold land. So what we got at that grand solar minimum? Surface temperature was reduced. Europe, North America went to deep freeze. Alpine glacier extended over valley farmland. Sea ice crept south from Arctic. Dunab and Thames rivers and canals in Netherlands froze regularly. This was Mount the minimum, previous grand solar minimum. Furthermore, the drop of the temperature, the authors told in this paper, was related to drop abundances of ozone created by reduction of solar UV radiation in stratosphere. Delay between 10 and 50 kilometers of the Earth. The sun sent less, only 3 watt per meter squared, less. We have reduction of this ozone radiation. Why? What is happening? Happening what is, when we don't have this reduction, we have stable jet stream flowing and about the same path. Gulf Stream part of this path. But when we got less ozone affect planetary atmosphere waves, what they do, they cause the giant wiggles of streams going to the bottom, to the lower atmospheres. It kicks off North Atlantic oscillation, and the balance between permanent low pressure system near Greenland and permanent high pressure system to its south into negative phase. This is why we get this decrease of the temperature. And this why is 1 degree. It's essential for us. We are in the north of Europe. In North America, remember it was 22, 23 winter when the frost was in Canada minus 40 and snow up to the hill. So this is what is coming. So this is what marked the minimum in the 17th century.
Okay.
And this is about the minimum which is coming cycle 26. And the scientists found the minimum coming even when cycle 25 started. This is print from Royal Observatory of Belgium. Number of spotless days in cycle 25 increases much sharper than in all 25 cycles before. It indicates, guys, we are at the ground solar minimum. So if you look at ground solar minimum, we see in December 20, it was snow in Northern Africa. December 20. Then in summer it was snow in Ukraine, the Carpathian Mountains, in July 21. Then in January it was snow Amman in the Arabian Republic. And then again, we didn't have New York City underwater by 2009. Early snow in Canada, September 20, May 21, plus increase of the ice in Greenland and the Northern Pole. So contrary again prediction that the ice will be gone, it is not gone. It is keep increasing very nicely. And even NOAA said now that we full-blown ground solar minimum in 2020s. They admitted it. Gavin Smith shut them down, but they still admitted it at that time. So you cannot say that it is not this. Solar cycle 25 and 24 were weakest in the last 200 years anyway, but just wait for cycle 26. What showed you this is ice in 2012, this is ice 2013, increased, not decreased, as they say. This is the Brilliant Blizzard US in 2 weeks, 22-23, just to show. This is in New Zealand, 23-30 November 22. And this is brilliant, Grand Solar Minimum, South Africa, 21-23 September 2024, just recently. South Africa, they never had snow. Never, ever. But look at poor lion and the similar giraffes. Look at this white stuff. Said, for God's sake, where do they come from? So this is the thing is coming. Whether they like it or not, they can tell you anything. But the snow will be falling, and the consequences of it very significant. Even this year, I don't know if you read the news, but the harvest in Great Britain is the lowest in the past 100 years because of the cold summer.
Yes.
Yeah, you know that.
Yes.
So this is what, and this is not the coldest summer. The sun is still in maximum cycle 25, guys. Just wait 5 years. What I suggest, put a little, some garden in your house. Start growing something for yourself. Put stove into your fireplace, because you maybe boilers will not be suitable. And these idiots who at the government, they try to move you to electric everything, which will not be working, because no solar emission comes, it is reduced, and clouds will increase because of minimum. No wind, and we will not have power. If you don't have power, even your a gas boiler will not start because all timer works on the power. So guys, it is very serious. Will be shortage of vegetation period. We need to buy the food from Africa. So it will be golden food, but again, it needs to be supplied. Someone needs to deliver from the Mediterranean to all these lands to us. How do you know when they deliver? You don't know. So this is the main issue we're featuring, and they refuse to speak about it. They say it will not happen, despite it is happening already. You saw it. So this is what we need to look and to deal with it. What they do, have you seen this nice aurora borealis? Haven't you? Nice. I made pictures in my mobile phone, and beautiful color someday. But do you know that this aurora borealis, these are done in the UK, Ireland. This is in Australia, and this is in Newcastle. We never saw it in Newcastle. Actually, it is X-ray of chemical composition of our atmosphere. What I'm saying, everything what we see in the color, it's scattering of electron on the molecules which are present in atmosphere. It shows huge pollution. We never saw so colorful aurora borealis is down. The down goes because magnetic field of the Earth also decrease. Not only magnetic field of the sun decrease, magnetic field of the Earth decrease. This is why your electrons, which come from the top, from the interplanetary space through magnetic field line from the poles to the bottom, they put this line, excited atomic oxygen at high altitude. Previously, we see this only in the near Arctic pole. Now we can see it in Northumbria, for God's sake. So obviously, we have all this pollution, atomic oxygen, another green line, and ionized molecular nitrogen. We are overpopulated with molecular nitrogen at the bottom.
Sorry, but oxygen and nitrogen are not pollution, they're part of the air.
Well, it is not pollution, but what it says, this particular excited oxygen should not be seen at the lower latitude. It should be seen at the 150 miles above. Why do we see it in the naked eye in the Northumbria? This is the thing which gives you indication there's something happening definitely with pollution of the atmosphere. This is X-ray and evidence for the future consideration, because I believe something happening anyway. So terrestrial temperature recovery after mini ice age. It was actually, what's his name, Akasofo. He first published this curve. Remember, I don't know, some of you probably remember, they predicted the temperature will increase after Mann published this hockey stick, the temperature increased by 5 degrees. And Akasofo said, all right, this guy produced linear interpolation from the temperature maximum and produced this increase. Now they reduce it for 1.5 degrees, but this is the temperature which Akasofo produced. This is a variation related to the solar activity, maximum, minimum, maximum, minimum. But this trend of increase is not related to the sun, to the solar activity at all. This one, different topic. So there is some point that solar activity now, I've proven to you, start reducing, but the temperature was increasing before the last 5 years. And this is what they say. It is not sun. Because temperature increases, sun cannot produce increase. It has to be the greenhouse gases. I don't know why they decided greenhouse gases. Maybe this is the only one they knew, they saw, I don't know. So anyway, at that time, when you look at that, you think, oh, maybe there's something in there. When I saw this plot, I didn't have much objections. I have to say, I came to the climate science from solar physics and high energy particles. I wrote the book on particle acceleration and transport. I run all these 3D big codes and everything. So they just started pressing me and pushing me doing this science, because the more they say you're doing rubbish, I said, no, I'm not doing rubbish. I'm a good scientist. Let me show you, I do not rubbish. So what I look at in 2007, if we are heating on the Earth with greenhouse gases, who is heating Jupiter? It has typhoon coming Jupiter at the same time when we have this here increased temperature on Earth. Even more, if America would sign Paris Treaty, maybe we stop heating Jupiter, do we? This is the thing. And this is what I found in 2007. Nothing changed. The CO2 ice on Mars in 1999 was more ice than 2001 was maximum. So ice was melting on Mars. So obviously we are heating straight from here. Wow, we are super gods, aren't we? This is the thing. But the Martin would sign Paris Agreement as well. This is my point is. And they now try to remove. In order to find these pictures now, I need to dig on Google 1, 2, 3, 5th page. Now they put their own thing. They try to hide what happened in another planets. So this is what we have. So yes, we can have forecast possibility, but increase of the temperature is here. But are we sure that increase of the temperature comes from the greenhouse gases? And again, we done paper. Remember, I have this formula. We calculated this formula for 120,000 years. This is my calculation, at least for 12,000 years. What you can see now, we discovered that actually the cycles repeat. Every 5 cycles are semi-similar. This is like triangle. This is higher, triangle, higher, extended, higher, and so on. So these are like super grand cycle. Not grand cycle, but super grand cycle. I said, well, how is super grand cycle happening? So it was paper we published 2019. So what we decided, we discovered that basically this zero line in here is not zero. What it says, it fluctuates very nicely, periodically, with the period about 2,100 years. Which tells me, because the oscillation is so periodic, it has to be kind of orbital motion. It cannot be done by the sun. Nothing on the sun can produce such a nice period. You saw my 2 waves. They're not so nicely, I needed to clean them up to distract some waves, but they are not going so nicely exactly 11 years. They're going with different shapes, but these are very nice shapes, absolutely like sine of a sine function. Then we look at the data. It was Reams et al., and they found the period about 2,100 years in the variations of the C carbon-14 in trees biomass. It goes there. So what we look, where we are now in this cycle. So now that we are now here, minimum was during the minimum, and if you put on top our curve, this magnetic field curve, you can see that magnetic field moves toward the northern polarity, which tells you that the sun becomes closer to the Earth when the Earth inclined to it with the northern polarity. This is the only thing you see that. So how it could happen? We found this period, 2,100. Look at the data of solar luminosity in last 12,000 years. by Stan Hibbeler and Weir, and we got these cycles 364, 2243 from Stan Hibbeler, and 2300 from Weir. So definitely we have this big cycle, and it is unknown. So you know how it's called? It's called Halstead cycle. They know it does exist. They simply didn't link it to the solar location. So what we needed to do, we needed to exclude, remember Milankovitch cycles. So different variations of obliquity of the Earth, eccentricity, longitude of perihelion, precession, give period from 15,000 to 100,000. We have 2,200, none of them suitable. So forget about Milankovitch cycle. What it should be, it is solar inertial motion. What it is barycenter of the solar system. When Kepler put the theory of planet rotation, Newton has not yet published his structure about gravity. So he didn't know about gravity. He put the planets go on the orbitals according to the numbers and so on. And since Newton published gravity, no one bothered to calculate what gravity on the sun these planets put on. Only Joshi, in 1965, he did his calculations, and it turned out that actually the sun can move up to 4 solar radius or 2 solar diameters around this barycenter. So not only Earth moves around barycenter. This is how sun moves about barycenter. And this simulation is done actually by NASA in Meadow Observatory. You can download and see how it moves. It is known for 100 years. They simply didn't bother to look at. So this is how it moves. What it means that my sun is not sitting in the center, in the focus of the barycenter, but my sun will come closer to the Earth during spring equinox, March. This is what is happening now. This is why we had very warm April, May, June, and not less. And this is AGB people, Ken Rice, specifically from Edinburgh University, here near you. He said, no. All planets rotate about barycenter, but the Earth follow with the sun with this solar inertial motion. At that time, I didn't have ephemeris from NASA. So basically, based on this Rice objection, they retracted this paper, but keep it on the website so you can see it. This paper from 2019 was retracted on the 1st of March 2020. It is on the website, and we got on the COVID restriction. I had plenty of time sitting at home. Instead of licking my wounds, I went to the NASA website. I said, okay, I download distances. Sun, Earth distances, heliocentric coordinate. Voila. I got these distances from January 1600, 1726. And you see how nicely the distance is different. Because every year the sun comes closer and closer to Earth. The distance is decreasing. And furthermore, look at that. My winter solstice is not happening in this particular millennium in December. My winter solstice happened in January. 2020 it was the 5th. 2024 it was the 6th of January. By 2600 it will be 16th of January. This is why we have increase of the temperature, because sun comes up closer to us. And I put these plots, they're available on my website, you can download them for each month, each day, for each month, for particular 3 years, every month. And similar happened with the December and summer solstice. I even put differences between. And I show the difference in distances was exactly as they mentioned in my paper in Nature, which they retracted. I wrote to the editor, I said, withdraw the retraction and send me apologies. I said, oh no, we cannot do this. You can publish elsewhere. I said, okay. I published it in the paper, in the chapter, book chapter, and now in 4 papers, calculated. But I published the answer on my website. So you see how dishonest they are. They cannot admit they made the error. I wrote to Vice Chancellor Edinburgh University. I said, you have a wonderful professor of celestial mechanics who was claiming for half year for the whole world that the sun, Earth follows the sun with solar inertial motion and the distance doesn't change. While NASA ephemeris say it does change. She wrote me. I said, either he is not professor of celestial mechanics, he doesn't know it, or he's telling us a lie, deliberately. She wrote me, oh, everyone has a right to have mistakes. This is it. Guys, I wash my hands. So, and again, it is on the website, publications related to it. I publish the answers. So everyone who wants to know that I'm telling the truth, it is the truth. It is on the website. So anyway, what we've done, what we see now in previous millennium, maximum of solar distances was in June. Now in this millennium, the longest distance will be July. This is why we have this increase of the temperature. And basically, what we got, my perihelion, apohelium, are not located on the longest axis of ellipse. It's located on this curve. This is why increase of the temperature in this millennium. And this is why we have to cross whatever Mr. Rice said. That's nonsense. I think he should be sacked for this one. So anyway, here I calculated using inverse square law solar irradiance and shown that irradiance also changes as required. And you are not allowed to calculate mean irradiance, because if you calculate mean irradiance, you miss the main points. So you need to calculate the irradiance by every day. And for the case, if you, what they do, again, you know this, I'm a mathematician, I know they are not, but I like how they playing with the numbers. You know, the statistics is the best way to cheat people. And they play with the numbers very nicely. They apply statistics developed for data with the normal distribution, Gaussian distribution, to the data with any distribution. This is what they, when they apply the statistics for solar irradiance from the last millennium to the current, they get difference in the about 1.5 watt per square meter, as they claim. But when I added every single day to the each year, discovered that 2020, 2400 increase of irradiance is about 25 watt per square meter for the whole planet, maybe 12 watt per square meter per each hemisphere. This is why we're having this increase of the temperature. And this is why I ask them, you underestimate the contribution of the sun. Your solar forcing is not fully correctly calculated. They refuse to add the solar forcing. This is the thing. This is the thing. They say this come greenhouse gases. But I have one guy, very nice German guy, Hardy. He didn't add about 20 or 12 watt per square meter, but he only added 5 watt per square meter to the radiative model used. And even adding this, he managed to find that the even 60% comes from the sun. But remember, my increase is 10. So I think 99% comes from the sun. I don't know, maybe something comes from else, but so far I don't see how any other gases how we can heat ourselves, not our planet only, but Mars and Jupiter. Guys, we are superhumans. We heat the other planets. When I found this extra heating, I thought, okay, I found when they made the mistake, but how on earth they fit this CO2 to produce this heating? So you need to do the second mistake, to add this heating into CO2. So I needed to dig, again, finish the COVID. The guy came to me and said, I give you money, just continue your research. I thought it is like playing, you won the million, give me 5,000. No, it was real. He given me money, I created my company, and this is why I'm continuing this research and found this. So I got at the, look, how they managed to fit CO2 into this game. Because CO2 should not. CO2 is nice gas. You know, in all the garden centers, they put CO2 to increase growth of greenery. How on earth they consider it is killing us? My gosh, you have to be very sick. So how they did it, okay, I look at the spectrum of the sun. This is spectrum of the sun, this is your O3, and this is your CO2 emission, which they get infrared emission, and they found it is very strong emission, and they think it can heat it. So what they put, come heating, fine. The only thing this guy forgot, this could be fine if you add extra, you had, let's say, 1,000 molecules of CO2, then you had 400,000 molecules. If we add them together, they increase heating. But this only works if you have vacuum. If you don't have surface, it is not a pack. But if you have molecules around, they do not allow you simply heat. They do radiative transfer. It's like you are coming to somewhere to view something. Can you get from this point to there if you have a huge number of people in the soccer? No, you need to move among the people, hit them, squeeze between them to get them. The same is radiation. Comes radiative transfer, it turn out, this is my CO2 emission, and it is very in a pack. It has opacity 400, which means that on the line of sight, I have 400,000 molecules of CO2, which are emitting. But can we see all this emission? Of course not, because this emission is calculated through the integral. You need to integrate all the emission coming from different layers to the line of sight. And if you do an emission, you need to multiply by exponential of optical thickness. And from general math, even if you don't know math, only E minus 1 it is comparable. If E minus 2 or 10, this term equal to 0. So basically, what is happening with the optical thickness, happening with this, is optical thickness less than 1, you have increase of the radiation, the more particles or the more molecules you have. But if my optical thickness greater than 1, you have saturation. You have emission only coming from the layer optical thickness 1. But these guys, they add it all together. And this is the biggest mistake they did. This is the thing. So not only you found where the heating comes from, but also found how they manage. They simply don't know basic theory of radiative transfer, which in solar physics we consumed it 60s, 70s. It was a very big boom. My PhD was in radiative transfer. This is why I'm not that smart, but my PhD supervisor, she made me smart. I need to write a nice memory about her. We write in because she is the one who made me a scientist. And she made me understand radiative transfer, and this is why I understand this thing. So these guys simply made two mistakes. They ignored the sun, and then instead of using the saturated radiation come as to the bottom, to the earth, the same come to the top. And then they said, oh, on the top you have decrease of the temperature, and they try to find why decrease of the temperature. No decrease of the temperature, it is simply no radiation coming, because the layer has 400 optical thickness. And only from layer 1 you see the radiation. It will keep coming and come. If we start heating it more, or CO2 stop producing, it will heat until CO2 all come from the layer 1 and will be done. But we keep producing the Earth's temperature increasing, which actually is the main source of CO2, because CO2 abundance trail the temperature increase by 1.5 years. This recent paper by Greek people show. So this is what I'm saying, that increase of this temperature straightforward. This is radiation of solar activity, but this is one related to the current Hallstatt cycle, because sun moves closer to the Earth, and it will be moving closer to 2600. So the temperature will increase. I calculated in the book, if you look at the book chapter, it is free download, section 5, it will increase for another 2.5 or 3 Celsius. So it will be much hotter. And it was much hotter beginning of Anna Domini. Remember, you live in Scotland. I've been working as a guide in Scottish tours for different groups, and I used to take people to the Roman baths in Scotland. They had at the beginning of the century Roman baths. They grew grapes in Scotland. It was 2,000 years ago. So we come into the same period. So it is not something unusual. It has happened before, and Earth had this. We got this about 60 Hallstatt cycles in 120,000 years, but maybe more all the time. So this is happening, and beyond our control, obviously. Oops. Instead of drinking, I'm pinching off. So this is basically brings me to my conclusions. Thank you very much. That the modern grand solar cycle, grand solar minimum occur 2020, 2053, and we have very different narratives to the government. What I appeal, spread the word, refer to my pages. Not only me, they have clientele whole group all over the world, including Nobel Prize people, people who got education before 1980, who knew math, and they supporting it. Please go and spread the word, join the forces, and make the government postpone this idiocracy to replace all the boilers, replace all the cars, because the only cars will be available when it is frost. It will be your petrol or diesel. Electric doesn't work below -2. Electric battery does not work. Folks, don't buy this crap.